Earth has a pulse every 27.5 million years that brings eruptions and mass extinctions. Before we start, please like the video and subscribe for more. Thank you. Disasters such as volcanic eruptions and mass extinctions appear to occur on a regular basis, as dictated by a pulse that beats every 27.5 million years, according to a new study. Researchers used advanced radio-isotope dating technology to precisely pinpoint disasters such as sea level rises and volcanic eruptions. They discovered that such events are not random, but rather appear to be linked to a recurring cycle of major geological events. The last cycle occurred 7 million years ago, implying that it will be another 20 million years before such events occur again. Many geologists believe that geological events are random over time, said Michael Rampino, a geologist and professor in New York University's Department of Biology. However, our research provides statistical evidence for a common cycle, implying that these geologic events are correlated rather than random. The findings were published in the journal Geoscience Frontiers. Researchers have previously proposed cycles of major geological events ranging from roughly 26 to 36 million years, including volcanic activity and mass extinctions on land and sea. Many events, however, have been difficult to date precisely. Significant advancements in radio-isotopic dating techniques and changes in the geologic timescale have resulted in new data on the timing of past events in recent years. Rampino and his colleagues examined the ages of 89 well-dated major geological events that occurred over the last 260 million years. These events include marine and land extinctions, massive volcanic lava outpourings known as flood basalt eruptions, oxygen-depleted oceans, sea level fluctuations, and changes or reorganizations in the Earth's tectonic plates. They discovered that these global geologic events are generally clustered at 10 different time points over the course of 260 million years, grouped in peaks or pulses roughly 27.5 million years apart. Researchers believe that these pulses can function in the Earth's inner activity cycles, geophysical processes linked to platform tectonics and climatic dynamics. Alternatively, these events may also be accompanied by similar cycles within the space orbit of the Earth. Rampino said, "We support this case, irrespective of the sources of these cyclic episodes, with a mostly periodic, coordinated and intermittently catastrophic geological record that deviates from the ideas held by numerous geologists." Every 26 seconds the Earth pulsates. And seismologists do not agree why. Seismometers on multiple continents have detected a mysterious pulse like clockwork since at least the early 1960s. The Earth shakes every 26 seconds. It's not much, certainly not enough to feel, but it's enough for seismologists on multiple continents to see a measurable blip on their detectors. Despite the fact that this pulse has been observed for decades, scientists cannot agree on what is causing it. The pulse, or microseism in geologist terminology, was first observed in the early 1960s by a researcher named Jack Oliver, who was then at the Lamont Doherty Geological Observatory. He is best known for his later work, which provided some important early evidence for shifting tectonic plates. Oliver concluded that the pulse was coming from somewhere in the southern or equatorial Atlantic Ocean, and that it was stronger during the summer months in the northern hemisphere or winter in the southern hemisphere. Jack didn't have the resources in 1962 that we had in 2005. He didn't have digital seismometers. He was dealing with paper records, says Mike Ritzwiller, a seismologist at the University of Colorado, Boulder, whose team discovered the strange pulse decades later. In 2005, Greg Benson, a graduate student at the University of Colorado, Boulder, was working with seismic data in his lab. When his advisor entered, he asked him to show him what he was working on. According to Ritzwiller, Benson pulled up some data and there it was, a strong signal from a long distance away. As soon as we saw this, Then postdoctoral researcher Nikolai Shapiro and I knew there was something strange going on, but we had no idea what it was, Ritzwiller says. Perplexed, the team investigated the blips from every angle possible. Was there a problem with their instruments? Or perhaps their analyses? Or was there really seismic activity going on? All indications pointed to the latter. They were even able to pinpoint the pulse's origin, a single source in the Gulf of Guinea, off Africa's western coast. They also dug up Oliver's and Holcomb's work and published a study in Geophysical Research Letters in 2006. However, no one has really confirmed the cause of the regular seismic activity since then. Many people believe it is caused by waves, but others believe it is caused by volcanic activity. Though this particular pulse is intriguing, the fact that there is seismic activity during a quiet period, that is, not during an earthquake or volcanic eruption, is old news. There is a constant background of subtle seismic noise around us. Patterns in this ambient seismic noise can be studied by researchers to learn about the Earth's interior, as Ritzwiller's group has done for decades. There are plenty of other continental shelves and volcanoes around the world that, as far as we know, aren't causing seismic pulses. However, despite the fact that the pulse has been observed for nearly 60 years, no one has been able to figure it out. That doesn't mean it's not worthwhile to research, says Ritzwiller. We are still waiting for a fundamental explanation for the cause of this phenomenon, Ritzwiller says. I think the point of all of this is that there are very interesting fundamental phenomena in the Earth that are known to exist but remain hidden. He believes it may be up to future generations of students to solve these great mysteries. Thank you for watching. Please like the video and subscribe for more.